In 1989, I made the decision to go to Detroit. There were a couple of reasons. One was the advancement of my career. Obviously, Professor Mansfield, even then, was a top scientist, and you tend to get underneath his umbrella a little bit. And I felt that my career needed to be seen in its own light, as it were. And so one of the reasons for going to Detroit was to develop my own career. The second reason was, again, I was interested in stroke. I thought that MRI could have some major applications in stroke. And stroke is a condition which affects black people. And so, not surprisingly, the Americans made their National Stroke Centre at the time Detroit. And so that was where there was plenty of access to these type of patients. I have to say also I thought it would be a life-changing experience for myself and my family. I had 3 children at that time, and we had a wonderful time. They were the second centre to get a 3 Tesla magnet at the time, second one in the world. So part of the attraction also was to get my hands on the latest top range of high field magnets. And so the first thing I had to do was actually get the thing working. So we started, at the time, diffusion was one of the areas that we wanted to exploit. Diffusion is the random motion of water molecules in anything like a liquid, a glass of water. In the brain, the diffusion of water molecules takes the water in and out of cells, and therefore it is actually sensitive to the structure of the tissue itself. Now, the diffusion coefficient changes within minutes of brain tissue running out of oxygen. And this mechanism is thought to reflect the swelling of cells. Water, it goes into cells. Inside the cell, it's in a lower diffusion environment, and therefore the diffusion coefficient, when the cells swell and there's more of the water inside the cell than outside, that causes a reduction in the diffusion coefficient, which we can measure in an MR image. The way we measure it is simply by putting enormous magnetic field gradients into the imaging experiment, and those magnetic field gradients sensitize the position of water in 2 points, and if the water has moved between those 2 points in time in this very large gradient, the signal is changed and you can actually measure the diffusion coefficient. So it's a very important parameter because it changes very quickly, and literally you could almost hold your breath and see the changes in the brain. It's therefore very useful for looking at ischemia such as a stroke.